All right. Well, good morning, good afternoon, good evening to everyone. Hope you can hear me okay. This is Sanjay Kumar, the moderator for this panel on edge computing and artificial intelligence. I am delighted to have a very distinguished and esteemed panel with me on the phone and on video. Thank you for taking time to join the session. What we will do is we'll start with a poll. Then I'll have our panelists do introductions. We'll follow up with the second poll, and then I'll be asking the panelists some questions as we move forward. Certainly put your questions in the chat, and I will pick them up and ask them for the panelists. So here we are with our first poll. So please respond with one of the following options. Select what describes your role. You're a manufacturing operation decision maker, an IT decision maker, developer, engineer, data scientist, service provider, consultant, or other. Please feel to type in chat if one of these roles is not what your role is. Give you 20 seconds or so to respond. We have about 97, almost 100 folks. Some folks are typing in the chat, so thank you for doing that. Okay. Let's see what our poll says. All right, good. So we have a good audience, variety of roles for manufacturing operations and IT, development, data scientists, service providers, others. I see cybersecurity, product management, director of technology, scientists in academia, advancing the practice of IoT. Oh, awesome. So wonderful. We also have a student on. Great. So I'm glad to see we have a wonderful audience here. All right, what I'll actually do is introduce our panelists. So I'm going to start with Dean Bartles. So Dean, over to you.
Good morning, good afternoon, good evening. It just says Sanjay said, depending on where you are. So my name is Dean Bartles. I'm the Chief Executive Officer of a fairly new company we formed last year called the Manufacturing Technology Deployment Group. My two primary subsidiaries I have is the National Center for Defense Manufacturing and Machining, which runs the National Additive Manufacturing Innovation Institute, branded as America Makes. So if you're in the US, you've more than likely heard of it if you're involved at all with additive manufacturing. And another new company we stood up last summer called Advanced Manufacturing International. And their mission is to help small medium manufacturers with their journey towards smart manufacturing and Industry 4.0. So happy to be part of this panel. Looking forward to the discussion. Thanks, Sanjay.
Great, thank you, Dean. Really glad to have you here on the call. Next is Dave McCarthy.
Thanks, hi, Sanjay. Hi, everyone. My name is Dave McCarthy. I'm a research director at IDC. So for those not familiar, IDC is a global market intelligence and advisory services firm for technology industries. And I joined IDC. Prior to joining IDC, I came out of the industrial IoT space. And it was one of the areas where, as companies, whether they were manufacturing companies, oil and gas, energy, transportation, all the types of companies that I would work with, starting down the IoT journey, a lot of them started realizing that, instrumenting equipment and connecting equipment and extracting data wasn't enough. And that's why I think today's topics around AI and how AI helps companies make sense of this volume or deluge of data that's coming in, and edge computing as a way of sort of extending infrastructure that allows you to move multiple workloads between cloud, core, and edge locations, kind of all comes together with IoT to do the types of things that manufacturing companies are trying to do, whether it's things like improving operations or new products and services, or even kind of new customer experiences. All of these, I think, are improved by leveraging the technology that's available. So at IDC, we look at this in a couple of different ways. One is the technology components themselves. What is out there today? How is the IT world and the OT world sort of converging around those? And then we also take industry-specific views. So, how do these technologies come together in many different vertical industries. So I'm glad to be included as part of this panel and looking forward to everyone else's opinions and seeing how we can kind of improve the industry overall by taking advantage of this. Thank you.
Great. Thank you, Dave. That's wonderful. We're glad to have you on the panel. So next we have Tibor Yassi. Please go ahead, Tibor, and welcome you to the panel. And I'm sure audience would like to know more about you and your role.
Thank you, Sanjay.
All right, so I see you're sharing a screen here.
So people, can we control everything?
We feel the need to control everything. But can we? Can we stop a scream? A tear from falling? Is it possible to laugh in silence? Love a bit? Emotions come like waves. You can feel them crashing against your walls while becoming stronger. You cannot choose when they come. You cannot choose when they go. So here is the deal. Let your emotions be. We will control all the rest. Somatic controllers for everything that can be controlled.
I cannot see your faces. And I'm sure you are wondering how we at Siemens are helping today companies in connecting, in protecting, and in turning data into valuable insights with artificial intelligence and edge computing. So to help you to answer to these questions, I'm here with you today, Thibaut Duassi. I'm a general manager and responsible of the industrial computing portfolio at Siemens. So happy to be here with you, and I'm looking forward to answer to your questions.
Thank you, Thibaut. I think that's been one of my most unique introductions to panelists and speakers for a long time. So one, thanks for sharing that video. And thanks again to the panelists. Looking forward to the session. Before we go to the Q&A and additional information, I'd like to have another poll pull up. We'll have you answer another quick question for us. Just give us a few minutes. Here we are. Okay. And again, just to better understand where you are in your edge computing and AI or industrial IoT initiatives, give us a sense of where you are. You're approved, you have initiative and it's in progress, you've completed one and seeing business value, ROI, or you haven't been able to justify the initiative, you started the project but did not yield results or cancel the project or not applicable. And thirdly, if you have a comment to share about where you are in your project, if one of these don't necessarily apply, feel free to put them in the chat. All right, we'll give a few seconds here for folks to respond. All right, okay. It's always interesting to get a cross-section and perspective of where you are on your edge in AI or industrial IoT initiatives. Wonderful, 21% approved and in progress. Now that's fantastic. Completed and seeing business value ROI. Oh, wonderful. We've got 9%. Unable to justify, which is okay, understandable, 13%. Started but did not yield results for canceled project, 14%. So I'm sure lots of lessons learned, and 43% said not applicable. That's great. I think that's great to know where you are in initiatives, what sort of results you have achieved, or where you are on your journey, or your journey didn't quite pan out. So thanks for that. Okay. So as we get into the discussion, perhaps one thing would be useful from an audience perspective. I think everybody has a thought of what the definition of edge in AI is. What I'd like to do is ask the panelists, and let me start with you, Dave. Perhaps from your perspective, would you share what you believe is the definition of edge computing and AI?
Yeah, absolutely. And it is certainly one of the questions that we get a lot at IDC. And it's also one of the more difficult questions to answer because it isn't always the same answer for everyone. I think at least on the edge computing side. Certainly, I think, one way to look at it is, the edge is applications, infrastructure data that's outside of centralized resources. So if you're a company that uses a lot of cloud-based resources, then your edges would be things like physical on-site locations, or maybe even things that are in the field. For other organizations, and more commonly, I think in a lot of industrial operations, your core might be a primary on-site data center. You're not using the cloud very much today. Not every company, despite the headlines, is. And so like that's your core. And so really what I mean here is that there is a little bit of a, the edge is in the eye of the beholder. You need to kind of know where your center and your anchor is in terms of understanding your edges. And in a lot of cases, I think a lot of the edge stuff has to do with things where you have remote management of the systems and the equipment that's out there. And you have different security contexts that you need to maintain in those situations. So that's certainly like the edge side of things. And then of course on the AI side, it's all about saying this fire hose of data that's being turned on by all of these new remote systems can be complicated. It's complicated in the fact that most companies underestimate the volume of data that comes in, and they also underestimate the noisiness of that data. And maybe even thirdly, they underestimate the importance of integrating that data with other systems. It's not really until you can kind of solve all three of those things that you can actually understand like the meaningful, insights, as many like to say, to apply it to your business somehow. And so to me, the reason why I really thought today's discussion topic was important is, IoT solves I need new sources of data. AI helps solve I need to understand that data, and edge computing is a way of taking that and putting it right next to the critical equipment or the critical processes that are required. So ultimately, a lot of the things that we've been talking about new use cases, all of a sudden become a lot more feasible if you can kind of put those three things together.
Great. Yeah. Thanks, Dave. I think it's always good to get that definition on any topic we talk about. I think our industry has coined with a number of different terms. Dean or Thibault, your thoughts, comments on that definition?
Yeah, I mean, I would like to build on what Dave just highlighted. So actually, the paradigm shift to the edge is placing the workload at the source, and at the end of the day, I do share the opinion of Dave, where we do see over 75% of the data were created outside of the data center. So actually, you need to place such the computing power and the processing at the edge, at the source, because application would needs real time processing to feed back the right I would say action that would have an impact on the overall manufacturing processes to create productivity and efficiency.
Excellent. That's some interesting statistics there. That's being very informative. Dean, thoughts from your side?
I couldn't agree more with what's already been said. And we're involved in a project right now where we're installing industrial Internet of Things boxes, for lack of a better term, that have computing devices inside that are being installed right on the so-called edge, right by the machines. And these edge devices have the ability to collect all the in-process information that you could possibly imagine. We're focusing on additive manufacturing and collecting information about not only what's going on in the overall environment in the shop itself, but right off the machine as the parts are being printed. We're collecting a tremendous amount of information, the in situ process information that I believe will prove to be very valuable, going forward. So at the very early stages of this project, it's all about the edge computing and the collecting of the information. Later down the road, we anticipate getting involved more with the AI side of this and looking for trending patterns and things that we can do from a predictive analytics perspective and help these companies, especially these small companies, be able to change the parameters for their machines in order to yield a better outcome, depending on what that outcome is they're looking for. So very excited about this new field, and we hope to be able to help many small, medium manufacturers going forward with this.
No, that's great. Yeah, I think it's important to understand, where is the data, what's the definition, why is it important, to your point, Dean. Maybe just to build on that thought a little bit, at least for me, when people say edge, how would you describe that? So let's say, it's a conversation with your leadership or executive team, and you're trying to explain to them, like, what is this thing at the edge? It's a term that they may not have heard before. Would you have a way of describing it sort of in more layman's terms?
Yeah, I could give you one example. So I used to work for General Dynamics Corporation, and we had multiple plants that made various types of things. We did a lot of CNC machining of heavy metal parts, and we installed what you would call edge devices that had an adaptive control capability right alongside the machine. So these devices would be hooked up to a CNC lathe, for example, and monitor things that were going on that lathe and be able to override the G code on the program that was set for that machine in order to run more efficiently. So we were able to reduce cycle time by 20 or 30% through the application of this edge device. And that edge, it's right, literally on the edge of the machine, you might say. So imagine a small box, maybe 12 inches by 15 inches or so in shape, and you hook it up literally on the edge of the shop floor or on the edge of the machine is the best visual I could give you. But the computing capability of these small devices is tremendous and very, very low cost.
That's great. Yeah, thanks.
From my side, you can just look at the background. What I have here is actually edge could, as Dean just highlighted, it depends on the use cases and depends on the application. And according to the use case and application, we do associate a certain computing power. And then we allocate the right device and the right equipment. And then comes the software layer where we collect data, where we process data, we monitor the data, and we bring on a trained AI model application to realize impact on the manufacturing processes or on the product quality.
Yeah, and that's a good point, Tabor. Thanks for answering that. So actually, let me build on a couple of points that you brought up. So one is, I go back to and say, well, you're part of a service provider. I'm sure you have conversations at the CXO level. So what is your conversation to, let's say, a CEO of a manufacturing company, right? So two parts, sort of building on the definition of edge. And then two is, why is edge and AI so important? So how do you have the conversation, let's say, at the CXO level?
So actually, our way is to work with our customer as partner, because actually we approach them by bringing, I would say, our manufacturing know-how or our domain know-how combined with our integrated hardware and software. But on the other side, it's crucial that our clients, our partners, right, have a joint activities to help us to have a deep understanding on their manufacturing processes, on their overall architecture, data structuring, and so on and so forth. So our way is when we engage with our customers, we really have a deep understanding on our customers' pain points. Where are the pain points? Are we talking about improving product quality? Are we talking about reducing NCCs? Are we talking about anomaly detection? Are we talking about spot welding activities in the automotive shop? So once we identify the pain points, and once we build together with our customers a digitalization roadmap where both executives from both companies agreed on that roadmap, then we start to approach them use cases per use cases, bringing our industry know-how and their knowledge in terms of processes, data availability, and so on.
Great. Thanks for that. Dave or Dean, do you want to share your thoughts on that question? So the question is, one is, you're talking about what does edge mean, and you're also actually talking about the importance of edge and AI, at a C level, where, to Tabor, your point, right, what's important for them, right? Is it quality? Is it meeting customer needs or production throughput? So Dave or Dean, like, how would you have that conversation maybe at the C level?
Yeah, I guess I can jump in real quick first, because there is absolutely there's a technology discussion and there's a business discussion. And, when I was thinking about it for a moment, if I walked into a C-level office and started saying, hey, I'm really looking for some money for an edge computing solution, the conversation would probably last 2 minutes, because what does that mean and why do I care? Right. So I think the things that we were just talking about of, it always starts, it doesn't matter whether it's any of the IoT, the edge, or the AI, right? It always starts with, there is some sort of goal that executive is trying to achieve. And it does seem like in many cases, you're trying to, the easiest ones, the ones that are easiest to build ROI around are typically like the efficiency ones. How can I reduce material waste? How can I, make better use of labor? How can I, increase yield maybe, or reduce defect rate? All these kind of things that we know are the types of things that we're trying to achieve. You say, like, which of these are most important, and what would be like a meaningful KPI that we can improve on to be able to do that? And once you can kind of agree to that, then the question is, okay, well, how do we backfill then, or how do we architect a solution that lines up with that? And then when somebody was to ask about, like, well, then why edge and AI? What's wrong with just IoT that you've been talking about for the last 5 years? I think the big key to it is how real time and how automated you can get in some of these things. Because in my view, what was happening in kind of early phases, and I noticed in the poll question, it's a journey, right? Like some people are just still getting static dashboards put together. So AI seems like it's years and years away, and other people are further along, and it has to happen that way. But what I've seen is in a lot of cases, people are doing things in a very, what I call kind of offline way. Collect a lot of data, go bring it over to a data scientist. They'll run some experiments. They'll build some models. They might figure out, oh, we need to change a calibration setting. We're going to raise that temperature 4 degrees under certain conditions, right? And then they go back and they implement that and they see the results. And it's great for a proof of concept, but it's also very slow. It's very labor intensive, and you don't really get those meaningful things. Where I think you say, if you can kind of get past that idea of, like, here's what I want to do and show that you can do it, it's the edge and the AI that sort of complete that loop. So it becomes more automated. And you can get the answers faster. Those are, I think, putting it into those sorts of terminology and those kind of like value propositions, I think lands better in that type of scenario.
So Sanjay,
thank you. Yeah. Go ahead, Dave. Dean, sorry.
Yeah. So in the last 5 years, I've had the pleasure of serving as president of the Society of Manufacturing Engineers 1 year. I was the president of the National Tooling and Machining Association for about a year. And also, I was the founding executive director of the Digital Manufacturing Design Innovation Institute. So what did those opportunities give me? They afforded me the opportunity to go into lots of shops and talk to, C-level executives. But now keep in mind, there's a huge difference between talking to the C-level executive at Siemens, right, versus the C-level executive of a 100-man shop, right? And I tell you, the leaders of these small businesses, they're the ones that know how to run every machine in their shop, and they're very, very savvy. And when I would begin to talk to them about the subject of smart manufacturing, right, which is really this broader term that covers everything we're currently talking about, sometimes they would be offended right off the bat and say, well, what are you saying? Everything I do is dumb manufacturing? But then when I would get into explain to them and say, listen, what if I told you that I could predict when a key part of one of your machines is going to fail ahead of time, so that you could schedule your maintenance crew on the weekend instead of interrupting first shift production? Then I got their attention. So there are ways you can go in and talk to them about the real benefits of some of these technologies that we're discussing and get their attention right away, regardless of how high level they are. But like I said, a lot different talking to a 100-man shop C-level executive versus, like the chairman of, well, Siemens isn't a good example, because I'm sure he knows as much as we all do, but a lot of these big companies, the top levels of $30 billion companies, they really don't understand this technology, don't want to understand that they've got people below them that they empower to understand that. And that's who you really need to get to.
Yeah, I mean, I would like to build on Dean's comment. So actually, at the end of the day, if it's a small shop or if it's a big corporation, is how do we deliver a value in a total cost of ownership optimized way? So at the end of the day, how do we enable even the small, because we have also customer, a very small machine builder sitting in the middle of Germany, right? But at the end of the day, is all about value. How much saving, how much improvement in product quality, how much energy management he's gonna save, and so on and so forth. So at the end is how do we deliver value for the shops, for the machine builder, for the line builder, or for the big corporation.
Yeah, no, thanks for that. I think that's a good way to say what's the conversation, how is the conversation tailored to the audience you're speaking with. And certainly, Dean, you make a very important point about, a lot of times, and I've seen this, where we talk about algorithms and analytics, more often than not, it's actually the people who've been there and doing the work will tell you, here's what they look for, right?
Correct.
Here are the parameters that they know will affect something or an output, or they hear something and the machine they know is going to fail. So I think that's a great point. Let me ask, Dean, could you share an example of success you had? I know you've been involved in a few initiatives. I think it'd be great for the audience to hear about some of your recent projects and success you had. Would you like to do that?
Sure. So the current project that we're dealing with is a project with the U.S. Army. They've asked us to create what you would call as a prototype additive manufacturing supply chain. So we have identified about 50 different companies, small to mediums and sometimes large, that have a certain additive manufacturing capability. And what the Army has asked us to do is create a system that allows for the Army to have their 3D models for these various parts they want to have 3D printed, stored in a repository. And then the various companies that are interested in bidding on making some of those parts can pull down that 3D model. And this system that we're developing will have the ability to extract the information right from the 3D model and send it directly out to the printers. And as these parts are being printed, we're collecting a tremendous amount of in-process information, not just on the machine itself, which we are collecting quite a bit off the machine, but also in the general shop environment. All of that data is going to be encrypted, it's going to be tokenized, and it's going to be available in a Microsoft Azure Gov Cloud environment. And if there's certain parts of the information that the manufacturer wants to keep for themselves, and there's other parts that they've agreed to allow for the customer to have. But if there's ever a problem in the field with any of those parts, they will be able to go back and figure out from all the data that was collected and stored what may have happened during that process. I believe that once we have collected enough information in the right format, as Dave mentioned earlier, that's a big issue. Is when you collect all this data from all these disparate manufacturers, you got to make sure all the data is in a similar format so you can do some predictive analysis. But I think in the future, we're going to be able to trend that data and be able to help these small, medium manufacturers learn from each other, for those that want to participate, how they can improve those processes. So we're about in the middle of that project right now. We're going to be demonstrating the capability of the system here later this summer. And I'm pretty excited about it. I really think it has the future possibilities of helping lots of small, medium manufacturers with their journey towards this whole smart manufacturing type of process.
Great, thanks. So Dean, is the intent then to what you're doing for this project, would it be available to others to utilize? So
what I'm envisioning is something I'm calling the additive manufacturing commons, right? So yeah, I believe that there's enough companies out there of a certain size. I don't think this might be applicable that much to really large corporations that have multiple plants and can do this themselves. But a lot of companies that are of a certain size don't have the ability to trend patterns across multiple machines because they only have a few themselves. So if they're willing to play, along with everyone else, and people contribute this data to this repository where we can have some other expert companies that do predictive analytics be able to study that data and trend that data. And once they discover certain things, we intend to share that across everyone that participated. And we're not looking to do this for any kind of making money type of thing. We're interested in doing this simply to help small, medium manufacturers with their journey. We're a not-for-profit. Our mission is to help manufacturing in general, but especially small, mediums. But what I'm finding is even the large OEMs, at least in the defense business, right? The Lockheed Martins, the Raytheons, the Northrop Grummans, the General Dynamics, et cetera. They're very interested from an additive manufacturing perspective to see where this project is going. We have representatives from each of those companies on our OEM advisory board. And I think there's an opportunity for them to use this same system in their supply chains so that they also can help their suppliers become more efficient as we learn through the collective wisdom of all the data that's being collected across many disparate manufacturers.
Great. Thanks for that. It's a great example. Yeah, wonderful. I guess, Thibault, I'm sure in your organization, you've seen quite a few successes and a mix of successes. Would you like to highlight one that stands out in terms of successful edge computing and AI?
Yeah, absolutely. I would like to take one specific case in the die casting area, which is about anomaly detection. So what happened today is the part that being produced is being inspected at the end of line. So either manually or using automatic optical inspection. So what we did here, and at this customer, they have been scrapping per year around 10,000 parts, which represent between 2 to 4% defect rate. So what we did here, we really take the time to really understand the overall process, and we develop an AI model at the level of the die casting machine that process the data and predict if the part going out of the die casting machine is good or bad quality. And then we deploy that domain know-how application software to run on our edge computing platform, connected to our automation system to be able to enable the operator to take the right decision if he scrapped the part or not. So it helped our customer to early detect the failure and to reduce the defected product by around 30% on one side. On the other side, it helped to optimize the process and decrease the defect rate by around 40%. Because actually we are not waiting until the end of line to do the inspection. We are doing it pretty much upfront when the die finish its own job.
That's a great example. Any insight on what it took to get the project going, or lessons learned you could share?
So actually here for us, our biggest lesson learned was, I think what Dean highlighted, is the most important thing is the data quality. And what we discover here at this customer, which is pretty much automated, by the way, in one of the automotive customer, is that the data are coming from different parts, either from IT source software or even from Excel file. And what we discover when we are collecting those data and working hand in hand with their process engineer, with their die casting expert, we discovered that there was also a mistake in the entering the data in the Excel file. So, and I think that the first stage, sitting down with the customer, working together as a partner, is one of the biggest, I would say, element in achieving successful project edge AI implementation at the end of the day.
Great. That's a great point. Dave, you probably have a broad perspective in the role you have. Anything comes to mind, examples of success you've seen, or where sort of lessons that you may have seen in the broad spectrum of work you've been doing?
Yeah, sure. I mean, when I think of edge computing, leading in with that one for a moment, I mean, a lot of the places where edge computing makes a lot of sense is when you're dealing with either latency sensitive kind of decision making, like you need to be able to, understand data quickly and make an action, or these high bandwidth kind of use cases where the volume of data is just not feasible to, do analysis somewhere other than on site in order to get the answers that you need. And where those seem to accumulate, it's a lot of like video based analytics and machine vision, or even using like sound as a sensor. So like you have video and sound. And so we were just talking a little bit around, quality and defect checks using, cameras to be able to understand that. And of course, all of those are being trained on, AI models to understand, what the tolerances are and those sorts of things. But the other place where that happens too is in a lot of like safety scenarios. I mean, so things like just something simple stuff. In some case, what seems like simple stuff that can be critical for businesses, like are people wearing hard hats? Are people wearing their gloves? Maybe in today's world, are they wearing a mask? Like, and being able to do like almost compliance-based things using video and analytics to be able to understand that within the facility. And then even when we look at some of those other sort of like microphone or audio-based things, like things that you might have used a vibration sensor before on, maybe now you're doing more like audio analysis to see like, how like, sort of that same idea of like predictive, but like with bearings and things like that, where little differences in frequencies can make a huge difference in terms of like what you can see. And so all of these I kind of think are examples of like different types of sensors that are becoming universal, where edge and AI come together, and lots of companies are doing things like that today.
Thanks. Yeah, that's great insight. So I want to remind the audience attendees on the call that feel free to use the chat window for any questions you may have. The panelists, we are coming to the bottom of the hour, so I'll make sure if we have any questions, we can have the panelists answer them for you. So while we're waiting for questions, I have a couple of the questions I want to ask. So slightly different element of discussion. So, we talk about initiatives, successes, lessons learned. Dave, since you spoke last, let me ask you, in terms of what do organizations need to do? So one is the element of, right, you have something that you're going to address and solve with edge and AI. But that's not all, right? There's more to it, right? There's sort of some frameworks or organization elements that come into play. What are your point of view on that?
Yeah, I would say, I mean, so, and I noticed this in the earlier poll question, there was a good significant, or should I say a decent size of the people watching today's presentation that couldn't justify ultimately their IIoT initiative for probably various reasons. And I feel like less and less it's technical reasons. I mean, sure, there is issues sometimes with data formats and protocols and how do you take legacy things and marry them to current things. But in my view, that's not always the biggest problem. I mean, I think you can technically make some work, but it's getting the broader buy-in, from the organization. And I see a lot of companies, the ones that are more successful are ones where it's not just one particular business unit or one kind of operations team or reliability team trying to solve a point problem, but it's when it's been elevated to the point where there's some sort of like center of excellence around IoT or digital transformation, and you start seeing more and more kind of cross-functional teams where it's the IT organization and the operations or OT side of things kind of working together. And then going back to what we mentioned earlier of, if you're going to go into the C-suite, you better make sure that you're tying this to some sort of a business outcome. I think when you see that more top-down approach where you're getting that buy-in and support, those are the projects that often can, graduate into becoming real things. Whereas the science experiments or the fun little projects on the side, those are the ones that die off. That's probably like kind of the main things that I see that make a difference between sort of a failed, project in this space versus a successful one.
Great, thanks. And Dean, in your role, being part of industry organizations, are there any governance models or organization constructs or standards, things like that, that either are in place or emerging that in this topic of edge and AI that folks should be cognizant about?
Yeah, so ASME, of course, is one of the leading standards developers, and I would say you could, keep an eye on what they're doing right now in that space. I'm not current with, what the most recent standards are that they're currently working on, but I'm pretty sure a quick search of the ASME website, that's the American Society of Mechanical Engineers, by the way, you could find out some information. Also ASTM. Now at America Makes, which is the consortium for additive manufacturing here in the US, it's one of the 15 National Manufacturing Innovation Institutes. They have a group of representatives from all the different standards organizations that are working on a common set of standards for additive manufacturing, which I anticipate will include edge devices and artificial intelligence for additive manufacturing as they go forward. But that's still in the very early stages. So it's such an emerging space that I'm not familiar with what standards are out there right now. Of course, now there is one that I am very familiar with called MT Connect. Now, MT Connect is an open standard that was developed under the sponsorship of AMT, the Advanced Manufacturing Technology Association, that puts on the big IMTS show in Chicago every other year. And they've been working on this standard for MT Connect for a number of years. When you go back 10 years ago, when we first started thinking about MT Connect, you walk through machine shops and you realize that, just to connect the bar feeder to a CNC lathe, you have to write an API. I mean, nothing talked to anything, right? So that's what MT Connect's trying to do. It's a standard that if everyone adopts it, and by the way, more and more companies, more and more machine tool builders and software providers, and even edge device companies, they're starting to adopt this MT Connect standard so that things can talk to each other and information can come out of these devices in one common format, which is going to make all of our jobs a heck of a lot easier. So the IoT boxes that we're installing are MT Connect compatible. So I'd say that's probably the biggest standard that I'm pretty close to. I've been on the board of trustees for the last 10 years, and they've made tremendous progress in that space.
Great. Thanks for that. No, wonderful. All right. So I know there's a poll that's popped up, so that's a reminder that we're almost out of time. So let me just wrap. And there is one question, so perhaps maybe 30 seconds from maybe you, Dean, Dave, and then Thibault. The question is, just to wrap the session up, is what industries are adopting edge computing and AI today? And share your perspective. Let's wrap up in about 30 seconds. Dean?
Yeah, so certainly manufacturing. Now, I have friends that work for finance companies, and they're doing a tremendous amount of stuff in artificial intelligence. But my space, my whole world revolves around manufacturing, and I'm very, very excited of what's going on in this edge computing and AI, space for manufacturing. And of course, whenever you talk to companies, especially small, medium-sized companies, about hooking up edge devices out on their shop floor, they're going to transmit data to the cloud. Everybody gets a little concerned about cybersecurity. And there are solutions out there. Just one example, we're working with a small company called StrongKey. They're one of our alliance partners, and they've got a very low-priced appliance that we can install along with their IoT edge device that will encrypt and tokenize the data, so to make sure that even if someone could possibly hack it, it's useless to them. So that's a big area of concern that I wanted to make sure we mentioned and covered. But yeah, manufacturing across the board is really turning to edge computing and AI. It's going to be a really hot space for a number of years to come.
Great. With Thibault, from your perspective, I'm sure Siemens covers tons of industries. Any sub-vertical or type of industry that you've seen adopt edge and AI more than others?
So we would see today a lot of traction coming from the automotive industry. So actually, the automotive industry today is really forging ahead in comparison to other manufacturing industry when it comes to standardization, when it comes to automation. And with the challenges that the automotive industry is facing, they see clearly the need to implement edge computing and artificial intelligence to get more productivity, to get more efficiency.
Great, thanks. And I want to close, Dave, your final comments on industry or sub-industry.
Yeah, sure. I mean, I think the reality is I cannot probably identify one that isn't using this in some form or fashion. And maybe the way to think about it differently is there's a difference between, like a PLC on a manufacturing line has been there for decades, and that is a form of edge computing, right? So you can say manufacturing has been doing edge computing for decades. What's changing, of course, it's becoming more connected. There's more sort of low-cost hardware is becoming more standardized. So there's lots of improvements that's happening there. So in some cases, industries have been doing this for a while, but then there's like new versions of edge computing and AI. And I would probably use something like drones as an example, whether it's drones in logistics or drones being used to do inspections of railways and cell towers. I mean, there's lots of areas where it's like, that's a form of edge computing and AI that never existed before. So I always kind of look at it through what's been here before and being modernized and what's really brand new, because it's really being represented on both sides.
Great, thank you. All right, folks, we are at the bottom of the hour. And
question, Sanjay. Yeah, question, Sanjay.
Yeah.
in the Q&A, we've been asked about 21 questions so far. I've been typing furiously to try to answer as many as I can. So I've answered about 10 of them. But what happens to the other questions we haven't had a chance to answer yet? Do you know?
What we'll do, I'll work with Lucen and see if we can capture these and see if we can get responses out. Yeah, and unfortunately, we didn't have time for all the questions, but certainly we'll try and capture them and make sure we get them out to
Great.
as much as we can. But certainly, the session is going to be recorded. There'll be information sent out. The attendees all have your name, so if anyone needs to reach out specific to any of the panelists, you're welcome to do so. So on behalf of the panelists, it's been a pleasure to moderate the session. Thanks everyone for attending, and I appreciate your time.
Thanks for your leadership, Sanjay.
Thank you so much.
Thank you.
Everyone.
Thank you.
Bye-bye.
Thank you all. Yeah, so all the questions will be sent to the panelists and we'll get back either via our blog or the social channels. Thank you all. See you in the clubhouse or in the next session. Thank you all for joining.
Thanks, Lucen.
All right.
Thank you.
All right. Okay. Have a good day. All right. Bye-bye.